Hello, and in this lesson we will be learning how to actually run the query, how to use all these classes that we declared above to create tables in our database, provided we have set up our connection already by our engines. Take it from the lesson 1, the code here. I will be copying everything up to the session pool, to the lesson 2, put it here. Again, it's not a proper way of writing Python code. You like to have this all in different modules. So to be clear, what I mean by that is that you want to have a setup function for setting your engine and your connection string in one module, for example, call it setup, and another module for your tables, for classes of your tables, or having separate modules. One module called user with user model, another module with products and having products model. So something like that. But since we are learning, I'm showing you just this way. And now we have this session pool established, and we would like to create the tables using this session pool. How would we do that? It's actually pretty easy. I can use base class that we created in order to our tables to inherit from. And yeah, I don't actually need a session here. I can delete it. I can use just the engine, and I can use this base class. Remember, this is declarative base here, which the base class we inherited from in our every table declaration. And it has a method which called, not method, it's property metadata. And this one would have methods to create tables, like create all. And it accepts engine that it is using to connect to the database. So we can see that base class has metadata, and this create all method creates all tables stored in this metadata. Conditional by default will not attempt to recreate tables already present in the target database. We can also specify a list of tables objects if we want to specify, if we don't want to add all tables. But anyway, every table that used base class to inherit, the metadata here will have the information of every class that used base. But if you are storing these classes in different modules, in different Python files, you would like to import them first, because unless you do that, the base metadata will not know about your tables. If they are stored in another folder or another Python module, it should know in the context of this code here. So the class should be imported. Since we are doing this all in one file, we don't need to import anything. We just use metadata to create all tables. We also can delete all tables if we want to. Metadata drop all, we will have this method as well. So this method will drop all tables that's stored in database. And again, this method is not the correct way to create your tables, because you would like to track changes in your structure of your database. And tracking changes with just SQL Alchemy will boil down to just raw SQL statements, which is not convenient, harder to read, harder to support, etc. Because we are going to use Alembic to create and modify tables later. But right now, let's just run this code and see what errors we have. Type annotation for username can't be correctly interpreted for annotative declarative table form, or annotation should normally make use of the mapped generic type. So somewhere we have missed that in the user's username. Yeah, optional mapped. yeah, I believe we should put optional inside mapped. And the same thing we're going to use here. For refer ID optional, and here we'll have mapped. Let's confirm that other tables would not have this problem as well. So optional, yeah, we don't need session maker here. And let's do it again. And yeah, my database is not running right now. Let's make sure we have it running as well. PostgreSQL, exit it, let's make it running, and it is running, and let's run the code again. Yeah, finally no mistakes. You can see all the SQL statements just here, starting from some SQL alchemy statements that it needs to have before creating the tables. And our query starts here. Create table users, Telegram ID, big serial. By the way, this is not actually what we want here, but since we will be in Telegram always adding Telegram ID, I don't think there will be a problem because it's already unique in Telegram.
Yet again, it is better to use big int data type instead of big serial. While we technically can use big serials and manually insert values for it, but doing so might cause unwanted side effects or confusion for those maintaining the database. The main difference between big serial and big int is that big serial is auto-incrementing, and it actually creates something like a table that will store the last value. That is not what we want here. So what you can do to avoid that is just place auto increment false as an argument, and then it won't create a serial data type for you because you don't want it to be auto incrementing.
Then full name, username, language code, everything pretty much like we stated. Here it's specified explicitly timestamp without time zone, default now, not null. It stated the primary key and the foreign key, which references our users table. So if you compare with the SQL codes, the raw SQL from the beginning, it will be slightly different, but conceptually it's the same. Then table products, product ID, serial not null, true, title, description, not text, but varchar, but without length, almost the same thing, if not the same, created at, updated at. Then table orders, order ID, user ID, you can see it's big integer, created at, updated at, and foreign key. And for some reason, probably I need to check that. For some reason, it stated twice the foreign key. Let's see what's... It was in orders. It was in orders. User foreign key. It has mapped column, big integer. I think it's alright. For some reason, it stated twice the foreign key, which is not a big problem. Then order products. Order ID, product ID, quantity, primary key, foreign key, foreign key. And yeah, that's it. So if I go to my database and I like to use PyCharm database tool, I can select data source. I can say select PostgreSQL. Here I'm typing test user, test password, and database test user, pressing OK, and I will see all my tables created in public schema. Let's reload it, and here they are: users, our columns, products, everything like we wanted. And we can start running queries to these tables using SQL Alchemy ORM. But before we proceed, we will actually delete this, delete all our tables, You can see the queries. It's drop table order products, orders, products, users. And in the next lesson, we will start learning Alembic